Hello, everyone. Good morning, good afternoon, and good evening, respective of your locations, as we have participants all across the world. And so we are thrilled that you are here with us this evening for a session full of action-packed learning. And I'm Raksha Nagaria, part of the data science team at Analytics Vidhya, and I will be the moderator for this session. And for those who have joined us for the first time, a brief introduction about the DataHour sessions. The DataHour is a series of sessions conducted by Analytics Vidhya, led by top industry experts, and it is a fun way to understand the concepts of data science from the leading players in the data tech domain. And as the name suggests, it's 1 hour dedicated to data. And we are hopeful that these sessions are going to be a great source of enrichment for you all and value adding for our community members. So now on to our session today, which is writing reusable and reproducible pipelines for training neural networks. So a short introduction about the topic that reproducibility, it is an important topic in data science. It is crucial to have a reliable code if we want to ensure that our experiments are not influenced by randomness too much. So at the same time, it should be possible to change the code easily as we iterate over ideas. In this DataHour, Andrey will show an example of a working training pipeline for deep learning based on PyTorch-lightning and as a wrapper over PyTorch code and Hydra for managing configuration files. Now, on to our speaker in this session of DataHour, we have Andrey with us. He's a senior data scientist at Kareem. And he's a senior data scientist and IT solution at Kareem. It is an IT solution and consulting company. He has a vast experience of 10 plus years in the field of analytics and data science. He aspires to develop deep learning applications which could have a positive impact on the people that not only bring value to the business, but also improve the lives of users and clients. He's a Kaggle Notebooks has been ranked first in the kernel ranking and discussions grandmaster as well as Kaggle competitions master. So over to you, Andrey. The virtual stage is all yours.
Thank you for this introduction. Let me share my screen. I think, yes. Can I share my screen? Can I see my screen now?
Yes, it is visible.
Okay, great. So I was introduced, but let me introduce myself too. My name is Andrey, and today I will talk about writing reusable and reproducible pipelines for training neural networks. Training neural networks and deep learning models in general is challenging. It's very easy to make a mistake, and it can be difficult to find these mistakes. There are many deep learning frameworks and wrappers of them because people want to abstract as much code as possible, and they have different styles of doing it. And thanks to these abstractions, users can focus better on running experiments instead of spending unnecessary time on writing the code itself. Today, I'll talk about writing your own reusable code, how it depends on the task at hand, why should you write it, what functionality should it have, and how to start doing. So first of all, what is a training pipeline? The training pipeline is a code for training neural nets and producing something. Checkpoints with model weights, logs, and so on. Maybe, for example, images for interpreting the model. Of course, everyone who trains neural networks writes some training pipelines, but I talk specifically about reusable pipelines, which can be used for different data sets and different tasks without changing many things. At first, several words about me. I have worked for several years as a ERP system consultant. I was an analyst. I didn't program anything. I had multiple projects ranging from logistics to accounting and learned a lot about business. But later, I have decided to switch career to data science. I have studied by myself. I studied programming, statistics, machine learning, and other necessary things. And since 2017, I started working as a data scientist, and I have worked in multiple companies, multiple industries like banking, telecommunication, riding, and so on. In my previous job at MTSI, I worked on such projects like medical chatbot, video super resolution, book cover generation. Currently, I'm working on anti-fraud projects in Kareem. And as it was said, I have some other activities, for example, Kaggle, And all of this means that I have trained a lot of different models, implemented many projects, and started collecting my own reusable pieces of code. And in time, it evolved into a training pipeline. Well, at least for neural nets. It's more difficult to make pipelines for usual machine learning. And today, I'm going to share my experience. Here you can see the content of my talk. At first, I'll briefly cover different styles of writing code, depending on the type of the project and your goals. Next, I'll talk about general approaches to building training pipelines. Why should you do it, how to start, and I show the example of my current training pipeline. And then I will talk about some necessary parts of any training pipeline and about some nice to have things. So, styles of writing the code. First of all, it's one of the main things which, when we write the code, is for business. When we implement some projects at job, yeah. If we talk about business, it's important to get reliable results and a good production system. And in this case, machine learning could be only a small part of the system, even though it's the crucial one. Yeah. And usually the code could have some good quality. Maybe it could be tested. It should be well written. Maybe it's optimized for something. For example, if you need to have a high load, you optimize models for speed. Yeah. If you want to be able to deploy the model on small devices, you optimize the model for size. Yeah. If you need interpretability, you use simpler models and so on. So the emphasis on well-written code, stable metrics, and software engineering. A different style of coding is when you need to make some first prototypes or simply make something work. For example, you have a new task and you have little experience with it, you have limited time, and you need to try a lot of approaches. So you go to Stack Overflow, GitHub, Kaggle, take different pieces of code, slap them together, and hope that they work. Then when they work, you can decide whether to try something else or to rewrite this code and do something better. Yeah. So in this case, we just simply iterate and don't write many code. And Kaggle is somewhere between this because it's about fast iterations, so that and you often modify the code fast. You add some features fast. You drop some parts of code fast. And but at the same time, you need to be able to track the code and reproduce it, because if you want to optimize some metrics, you need to be sure that your changes to the code definitely improve the metrics, and they didn't happen due to some randomness or a lot of changes to the code. Yes. So as you can see, there are many different styles of writing the code, and writing training pipelines isn't relevant for all the cases. For example, you don't need to write a huge pipeline when you try new things and throw them away fast. Yes, but when you write training pipelines, you will have a more or less stable code. You will be able to run many models and compare them easily. You will be able to reuse your old functions and transfer them to different projects. Another important distinction is whether you are working alone or with a team. Yeah, if you're working alone, you can do anything. You could write the code however well or bad as you wish. Yes, the main thing is that it works for you. You can use it, you can reuse it, and so on. But if you work in a team, you have to compromise and make the code understandable. Maybe you have to write documentation. Maybe you have to write some tests. Maybe you have to write some comments. Yes, it requires more from you because not only you read this code, but also other people. Of course, there are different approaches, but I think that's enough for now. So how do we start writing the code and training neural nets? The default approach is taking some popular framework, for example, TensorFlow, PyTorch. Well, they are the most popular ones. There are others, and for example, JAX seems to be overtaking TensorFlow, but so far TensorFlow, PyTorch are the main ones. Yeah, and so you open the notebook, open the script, you write the code from scratch and train the model. The benefits is that you know exactly how everything works. You can share it with anyone, and if someone is familiar with the framework, they will be able to understand the codes, use it, and so on. But it takes a lot of time to write this code. Yeah, you have to write everything. You have to write training loops. You have to write any features, and so on. It's a lot of code. And if you have some complex cases like distributed training, some advanced machine learning approaches, and so on, you also have to write it by yourself. Experienced people can do it easier, but there are still a lot of possible problems. Yeah, you could try to run, for example, tests, but they have also their own bugs and take even more time. Yeah. Another approach is to use some high-level framework. For example, Keras is the most popular framework for TensorFlow. For PyTorch, there are many high-level frameworks, yes, and the nice thing is that you can choose the framework which you like. And the frameworks usually are very different because they focus on different things. Some of them try to focus on state-of-the-art approaches. Some of them focus on high-quality software engineering. Some of them have a strict API. Some of them are easy to use. Yeah, and it's nice that you can choose them. The main benefit is that you have a lot of pre-written code. You have a nice community. People will answer your questions and help you use the framework. But on the other hand, there is a problem that it's much more difficult to switch between them. If you were able to write the code in one framework, you'll spend a lot of time to change it to another framework. Yeah. The logical development of the first approach is writing your own framework. When you write trainers, you write classes, you write methods, you write abstractions, everything by yourself. Yeah, it's very nice to have. It will help you to understand everything, how everything works. But the main problem is that it will be very difficult to share your code. Chances are that no one will understand your code. So you have either to write the code very well or just to write the code for yourself. Yeah. And some kind of combination approach is writing your wrapper over usual frameworks. Yeah. So basically, you take, for example, Keras or FastAI and add your own abstractions. The reason to do it is while frameworks are great, often they are not enough for some specific use cases. So you have to modify something. Yeah. On the one hand, it's very nice because you can use all the features in the framework, and at the same time you can add anything whatever you want. But the main problem is that when other people try to use your code, they need to be familiar both with the high-level framework and with your own code. Yeah, so it's more difficult to other people. But I see that more and more people use this approach because it helps you, because you don't need to write everything from scratch and you can add whatever you want. So let's move further. What are the reasons for writing pipeline? First of all, if you need to write everything from scratch, as I have already said, it will take a lot of time and it's possible that there will be many errors. If you look at the number of issues for many popular high-level frameworks, you will see that there are dozens, maybe hundreds of issues. And if you think that it's possible to write your own framework without any bugs or without any errors, it's I suppose you should be very self-confident to be able to claim that you can write your own framework better than hundreds of people who contribute to popular high-level frameworks. Okay, then the thing is, if you take part in multiple projects, if you develop multiple projects, you will have some repeatable pieces of code anyway. Maybe you calculate the metrics by yourself. Maybe you switch optimizers. Maybe you optimize some pieces of code or you have optimization for some specific metric. Anyway, you have some pieces of code and you copy it from your first project to the second one, to the third one, and so on. In this case, converting them into classes or functions could be just a next logical step. Yeah. Another interesting point is that it really helps you to understand how the things work. Because I saw a lot of people who use high-level frameworks and sometimes they make basic mistakes or they don't understand basic things. For example, they can change the top layer of the framework, of the model. Yeah, they can't change the inputs. They don't know how the layers work. Yeah? And when you write your own pipeline, you have to understand these things and it will really help in your job or in your further projects. And if you have a team, if you work on a specific projects together and use the same pipeline, it's much easier to share the code, yeah? Because if different people use different frameworks, it's much more difficult to compare the solutions, to compare the metrics, and having the same pipeline is much better. So how does one start writing a training pipeline? Usually people open Jupyter Notebook, Google Colab, or Kaggle, or whatever, and write the whole code in it. It's totally okay at the beginning, it works, yeah, but after some time, you should understand that it's not the optimal approach because it makes changing the code more difficult. It's difficult to versionize your code, it's difficult to commit it. So after some time, one could try to split the code into multiple parts. For example, a separate script for dataset, a separate script for model, a separate script for optimization. Then you could add abstractions, configurations, and so on. And after some time, your project becomes bigger and bigger and more modular. Yeah. And imagine that you need to work on a different project now. For example, you train the model for image classification, and now you need to train a model for image segmentation. Yeah. If your pipeline is quite good, you don't need to change many things. Well, of course, you will need to change your model and data loader, but most of the other things like training loop shouldn't have many changes. Yeah? If you are able to switch to a different task without many changes, it means that your pipeline is quite good. By the way, an interesting approach to checking if your pipeline is okay or not is asking some friend to try and run your pipeline. If this person can run your pipeline, well, for example, within a couple of days, then it means your code is pretty well. So let me talk about my approach now. My approach evolved over time. At first, I wrote my code in TensorFlow, then I wrote it in pure PyTorch. I have tried multiple frameworks, and currently my approach is based on PyTorch-lightning and Hydra. PyTorch-lightning is a high-level framework for PyTorch. It abstracts a lot of boiler code and lets you write less code, and it has a lot of flexibility and nice features. Hydra is about managing configuration files. It combines many configuration files and makes changing hyperparameters easier. I tried this pipeline in many projects, for example, time series, tabular data, name identity recognition, image classification. I trained it on multiple GPU and even on multiple nodes and didn't have to change a lot of things. So currently I am satisfied with my approach and want to share it. There are several core ideas of my pipeline. First of all, I have replaceable models. So it's easy to change the model, easy to change the data loader, easy to change some optimizers, for example. As I have said, my configuration files are managed by Hydra, and I'll talk about it in details later. And the most important thing is that values in configuration files can be changed in command line. Any value in any configuration file can be easily changed. And of course, as any pipeline, it has some logging and it is reproducible. So here you can see how configuration looks like. On the left part of the screen, there is a structure of my configurations. I have split my pipeline in multiple models, a separate part for augmentation, several parts for model, metric, optimizer, scheduler, and so on. And there is a main configuration file which combines all others. It's on the right part of the screen. You can see that in each folder, I have a separate line and I define the value. For example, I define the value of metrics that I am using accuracy, I am defining optimizer, I am using LMW, I am using reducing PyTorch scheduler, and so on. And it is easy to change any value in the script. Next, I have some general settings which don't apply to a specific model, but they're like general, like to make predictions or not, to convert model to JIT, and so on. And the last part is about outputs. So when I run my pipeline, I have a separate output folder for each run, and the name of the folder is defined here. So here it is a timestamp of my run when I launch the model, so that the different experiments don't override each other. Yeah. And I have a lot of configuration files. Here you can see an example, the reduce on PyTorch scheduler. So here I have the class name and all the parameters. Some of them are specific to this scheduler, like factor and patience. Some of them are specific to the framework PyTorch-lightning, like the metric, which is monitored, the step, like epoch batch, and so on. And the similar scripts are for all other schedulers. So it takes some time to write them beforehand, but then I can easily replace them with one another. And here is the configuration file for augmentations. There are multiple approaches to managing augmentations. Often people use Python scripts or YAML configuration files, and personally, I prefer configuration files. Here, I can define any combination of augmentations from the great augmentation library. They can be nested, for example, and after, when I run the model, this configuration file is loaded and is used in my data loader. And here you can see an example of using these configuration files. This is one of the nice parts of the project. For example, in my earlier pipelines, I usually imported everything which I needed. For example, I need specific optimizer, I import it. If I need a different optimizer, I add a line with import again. Yeah, but here I don't need it at all. As you can see, the optimizer is loaded based on the name of the optimizer and the same for the scheduler. So this way, if I want to, for example, add a new optimizer to the project, completely new one, so I simply need to add the configuration file and I don't need to load anything. Hydra has some internal tools to load the objects, but I use the function from a different library called Hydra because I prefer it and it's more flexible for my cases. Yeah, and this way the code is cleaner. You don't need to add unnecessary things. Now let's see the flow of running the pipeline. Yeah, here is the main function. I need to add the decorator from Hydra and define the path to the configuration file. Then this function gets the dictionary with the nested configuration files, and then I can use this dictionary and use its attributes and use it anywhere in the code. It's like a usual dictionary with attributes. Next is an example of running. So basically, when I run the default version, I simply run Python train.py. Yeah, but as I said, it's possible to change any nested value of the model. So you can see that I am changing optimizer. I am changing the model. I am changing a very deep parameter of the model, like the architecture trained. Yeah, so it's possible to change anything. And another nice thing from the Hydra, it's possible to launch a multi-run. So I define several parameters, in this case, different folds of the data model, and it will run 3 times on different folders. So this means it's possible to optimize hyperparameters without using some external things. So it will run multiple times, output the metrics, and we can choose the best model. And on the right, you can see the output of any experiment. The name of the folder is a timestamp, as I have already said. But it's possible to make some advanced naming scheme. And for example, to take the parameters from the command line and add them to the folder name. The main downside of this approach is that if you change multiple parameters, the name of the folder will be too long and some operational systems could have problems with it. But it can be nice when you are changing only a couple of parameters. There are multiple folders here. First one is Hydra folder. It contains the original configuration files and the overriding values, and the new configuration file taking into account the overrides from the command line. The code folder, well, it's definitely not the best practice because if you want to do everything correctly, then after every change, you make a commit, you commit your code to Git, and then you run the model. But of course, when we make small iterations, it's easier just to run the code. So in this case, I simply take all the code of my project and copy it in the folder. Well, yeah, it's not the best practice, but it works and it saved me multiple times in the past. Next, I have a log folder, which I create by myself and write the metrics here as an additional login. Of course, there are saved models. And you can see that there are multiple saved models. For example, PyTorch-lightning allows you to define top N models to save. And here you can also input some values in the name of the file. So here I'm loading the epoch name and the validation score in the name of the file. It's quite useful so that the names won't be overwritten. And then there are some default folders. In fact, one of the solutions to the long folder names is adding some experiment files. I mean by this that Hydra added some cool feature that you can add a separate configuration file which has all the overrides of all the levels, like top levels, low levels, and so on. And you can pass it to the model when you run it, and all the values in the configuration files will be replaced. It's quite useful, but I didn't try it yet. Okay, so it was about my pipeline. And are there any downsides to it? Yeah, of course, there are any downsides. There are some downsides of it. For example, first of all, it's based on 2 frameworks. And if any of these frameworks changes API, I have to change my pipeline and spend some time on it. Yeah. Also, if I want to add some feature, sometimes it's, I have to wait for the next version of the library, and I can't do anything before that. But otherwise, I'm fine with it. So now let's talk about some things which any pipeline needs. First of all, of course, the core of any pipeline is a training loop. Like we iterate over the data, we collect losses, we calculate the metrics, and have maybe some events. Yeah. Here you can see an example. We have some batches, we calculate losses on them, and we log them. We log the losses and the metrics. Yeah, it's sometimes it's better to have multiple functions, multiple methods for training. For example, you could have a separate methods for events on the training epoch end or on the batch end. Yeah. If you can abstract them, it's okay, but sometimes it's not possible to abstract them, and you need to have multiple methods for running the training. Next point, which is important, is reproducibility. In fact, in deep learning, sometimes it isn't completely possible to have full reproducibility because some layers aren't deterministic. And even if you set up torch backends could enable deterministic true, sometimes you may have some different values in training. But in most cases, such function should be enough to have to fix multiple decimal values when you run multiple experiments. Of course, it's important to have some experiment tracking. TensorBoard is the default approach and the default choice. And in fact, if you have never tried TensorBoard, I suggest you to try it because it's quite good and it has a lot of features, and maybe it will be enough for you. But there are many companies which develop their own solutions. Currently, I'm using, for example, weights and biases. They allow to have some web interface. They allow to have some nice features. And often they have a community of people who could help you. So you could try several of them and decide which one you like and use it later. Again, I talk about changing hyperparameters. I just want to say that there are multiple approaches to it. One of the most popular ones is using argparse. It's when in your main training script, you have these many lines with your parameters and you change them here, but it isn't very flexible. It isn't very easy to find the parameters here. Yeah, and so I recommend to use configuration files. In fact, it isn't really necessary to have many configuration files like in my code. Many libraries prefer to have a single huge configuration file, and it's fine. I think anyway, this is better than having and using argparse. And then every training pipeline should have some more features in their functionality. First of all, it should be easy to modify it for similar problem. For example, you train a model for binary image classification and now have a different set for binary image classification. You shouldn't have to change many things in the code. And even if you change, for example, from binary classification to multi-class classification, you also shouldn't have to change many things. Mainly, I suppose you should have to change the architecture and maybe the losses, and that's it. But if you have to change lots of things, maybe the pipeline isn't optimal yet. This may sound strange, but I have seen many pipelines which were purely for training. Like you take the data, you train the model on it, but there are no methods to make predictions. Yeah, it's strange, but I saw them. So pipeline should have some possibility to make predictions. And it should be possible to make predictions both with pipeline and without pipeline. Why should you be able to make predictions without pipeline? Because, for example, when you use the model into production, it's easier to make predictions using pure TensorFlow or pure PyTorch than take the whole project and put it into production. And also, it should be possible to convert the model, for example, to ONNX, to TensorRT, and to some other formats so that it's easier to use them in the future. Also, it should be easy to change the model. I have shown some examples of changing the code, yes, but also, for example, some frameworks have a lot of layers of abstraction. And if you need to change some line of the code, you need to traverse multiple nested levels of abstraction. It's difficult to understand what exactly you need to change. And I won't criticize this approach, but I don't really like it. And I prefer things to be easier, to be more modular, to be more easier to change. And of course, there are some nice to have things, configurations. I have already said about it, and I will repeat, configurations are the best. It's nice to have some templates for everything. Some high-level frameworks already have templates. For example, they have pre-written code for image segmentation, image classification, text classifications, and so on. And it's very nice that you don't need to think a lot when moving to a different task. It should be possible to train the model on faults of hyperparameter optimization. Sadly, it is lacking in many high-level frameworks because usually they focus on training a strong single model. Yeah, but if you want to do hyperparameter optimization, sometimes you have to hoop through the loops and have some difficulties. So it would be nice to have it in the pipeline. Also, it would be nice to train with stages. By this, I mean, for example, changing image size after several epochs, or maybe changing some loss optimizer by training. It's interesting. Some of the high-level frameworks already have it, and it's really useful when you are trying to push your metric to the best. Yeah. As I have already said, it's nice to be able to use your pipeline for a variety of tasks without rewriting all the code. And well, even though no one likes documentation, it's important to write it so that you can remember what you wrote a month ago. Yeah? And of course, it's nice to have some cool tricks, gradient accumulation, increasing dropout, and so on and so on. There are many possible tricks, and it would be nice to have them in pipeline and not to write them every time again. So here you can see some links to the resources which I used in my talk and to my own pipeline. And on the last screen, you can see my contacts. So thank you for my talk. And now I will start answering the questions. Let's see. At first, I will go through Q&A. The first question, I want to ask, in the neural network, there is the hidden layers. Is there a rule for determining how much we should set the units of hidden layers? No, there is no such rule. Well, there is a theory that a neural network with a single layer, which is huge enough, could approximate any function. Yeah, but in practice, one layer often isn't enough because we can't have so many neurons in it. And so I would say that there is no specific rule. Currently, deep learning is more like an alchemy. There are people try different things and hope that they will work. You can read, for example, surveys on Archive. There are many surveys on model architecture, ideas of doing it. There are ideas for neural architecture search. You can base your architecture on it, yeah, but there are no hard written rules for it. Next question. Is it possible to merge two different frameworks when building a model? I'd say that it's possible, but very challenging. Because there are many frameworks which have completely different APIs. For example, some framework is function-based, another framework is class-based. Yeah, so it will be difficult to merge them. You could try to take some bare bones from them. For example, you write a model using some specific framework, you add some methods to it, and use it in another framework in the training loop. In this case, it's possible. But again, it will be very difficult to do it. Okay, I think someone is raising the hand. Then you can ask the question. Is it possible for people to ask questions, or does everyone has mic muted?
I guess there is one more question.
Yeah. Okay.
I will read it out for you. It is, what is the most important part of the data pipeline? Is it same as big data pipeline?
Let's see. I think the most important part of the training pipeline is ensure is correct validation. So even if you have some mistakes in pipeline, some of them aren't crucial. But if you can't evaluate your model properly, then it will be all of this will be for nothing. Yeah, because if you can't be sure that your model is producing correct metrics, there are no leaks. So you can't say that the performance is well. So yeah, I think the main part is correct evaluation of the performance. Okay, next question. What is the tensor product that you advise to use to build pipelines? I'm not sure what you mean. I suppose if you mean PyTorch product, high-level framework, then there are multiple of them, PyTorch-lightning, FastEye, Catalyst. If you mean something else, please write your question again. Can you share the link to the slides? I'll share the link with the organizers and they will be able to distribute it, I suppose. Is there a way to interpret the trained model? Yes, but it depends on the model itself. For example, if we talk about image classification or image segmentation models, there is a library or approach called GradCam. This approach shows you for images which part of the image were important to the model. So for example, if the model is for object detection of dogs, then you will see on the image that dogs are colored and every other part of the image isn't colored. Yeah. If you talk about some easier models, for example, training text classification on back of words, you could use simply the weights for a specific word. Yeah. If we talk about some advanced models, then it may be too difficult to interpret the model. Yeah. So it depends on the model itself. Yeah. So I suppose there are some questions in the chat. Let me see them. Okay. Okay. Just advanced topic. What other frameworks do you recommend to manage configs apart from Hydra? First of all, it's totally possible to use configuration files without any additional library. So if you use Python scripts for taking care of configurations, you don't need any other library. You simply import the information from these Python scripts. Yeah. So, and as I said, for example, Hugging Face and some other popular libraries have single configuration files for a model, and they don't have many separate files. So it's totally possible to use just the configuration files without any management system. Yeah. Can it be implemented in computer vision models? Yes, definitely. I have used this pipeline for training computer vision models. Yeah. What is the most usable hyperparameter tuning? Grid search, randomized search, or other techniques? I suppose the question is if you have enough time or not. For example, if you have unlimited time and unlimited hardware, you can simply use grid search and try all the combinations of hyperparameters. Yeah, because it will be the best if you try everything. But usually we don't have unlimited hardware, we don't have unlimited budget and time, and there are libraries. There is Retune, yes, there is Optuna, there are bias optimization techniques. In fact, PyTorch itself has, I think it has Axe, this library Axe for hyperparameter optimization. The Hydra has some plugins for hyperparameter optimization. So there are many of them, and I think you can use just any good library, and that's it. There won't be much difference in performance between multiple libraries. Yeah. Okay, I think I have answered all the current questions. If you have any other questions, please write them and I'll answer them.
Okay, I guess there are not much questions as of now.
Yeah.
Let's wait for 2 minutes.
I think there is one more question.
Yeah.
Yeah, I see. Okay. To become a data scientist, what is a project we have to do? Well, you see, data scientist is a profession which could mean a lot of things. In some countries, data scientists, in some companies, data scientists work on data analysis and make dashboards, for example. In some other companies, data scientists train classical machine learning. In some other companies, data scientists work with deep learning models. Again, there are machine learning engineers and many other types of data scientists. Yeah, so in general, you need to know SQL, you need to know some programming language, preferably Python or maybe R. Yeah, and you need to be able to do some project end-to-end. So for example, collect the data, clean it, train the model, make visualizations, explain them, and share your analysis. Yeah, this should be enough to get you started. Does libraries like Aptuna are faster than grid search or randomized search? Yes, of course, because they are optimized for model performance. Because grid search simply tries to take only all the hyperparameters, tries all the combinations of them, and runs the model for each of them. Randomized search takes random combinations of parameters and tries them. Yeah, but special libraries have additional logic. For example, Bayesian optimization tries some hyperparameters, finds areas of good hyperparameters and delves deeper in it. Yes, there are many other approaches to optimize hyperparameters, and usually they are better than the basic ones. What is the learning path for new data science aspirant? Partly I have already said it. So you need to learn programming languages and do some project, yeah. And another idea is that you could look for multiple descriptions of jobs of data scientists in different companies, compile the list of necessary technologies, and study them. You don't need to know everything, but usually you need to know most of them. You could also take part in hackathons or other events when you could show your skills so that people could notice you and hire you. Yeah. When you compete in Kaggle, how does managing configs work for you? Do you create many notebooks with different params, or do you iterate in your machine and just use the Kaggle for inference? I suppose it depends on the task itself. For example, I took part in a competition last autumn. It was a ventilator prediction competition with some kind of time-based series, but basically it was a sequence-to-sequence problem. Yeah, I used my own pipeline for it, which I showed you, and I had many configuration files and run experiments through my command line. I ran it on my own hardware and on hardware in my company. I was allowed to do it, of course, and it worked pretty well. Yeah, but for example, if we take part in tabular competition, usually it's more difficult to have some pipelines. Yeah, so usually in this case, I have some functions in Python scripts. I import them in Jupyter notebooks and run experiments. In this case, I often change the parameters through Jupyter notebooks as I don't have any better pipeline for tabular competitions yet. Yeah. How do I know which activation function used when in neural network? A good question. There are two ways to do it. First one is to be based on the values of the activation function and the values which you need. For example, let's suppose you are training a regression model. So you need to output some values. And you know that the values must be positive. So for example, you predict price of something. Yeah. In this case, you may use a reload activation function because it produces non-negative values. Yeah. Another idea is that if you need to predict classes, then you will use sigmoid or softmax activation functions because they produce values between 0 and 1. Yeah, that's some examples. As for the values inside the neural network, it's more difficult. Some of the activation functions may result in exploding gradients or vanishing gradients. Yeah. So the good approach is just to see what other people use and try to use the same. And in fact, most people use the same activation function and don't try to optimize it because the performance improvement often isn't that much. There are new activation functions which appear every year, and often the improvement isn't very big, so you can just not focus about it too much. For a job in data science field, how important it is to understand and implement research papers and how to keep up with them. I would say that it's most important if you are taking part in deep learning, if you are training neural nets. Yeah, but of course it depends on the job itself. Yeah, because let's see. For example, if you are routinely training the same models, for example, for classical machine learning problems, chances are you will never look at any scientific paper. Yeah. But for example, if you again work in a big company and you have enough time and resources to experiment with new things, you will have to look at the research papers. So for example, when I work in anti-fraud department, sometimes I try to search for modern approaches and use them. But of course, if you are working with texts, audio, images, you are much more likely to work with research papers. Yeah, but I think it's just at least it is needed for at least middle or senior level. It isn't necessary for junior level. Another question. Can I build a people identification system, security webcam on a CPU into integrated GPU, or should I work on cloud? I think there are several steps to building such a system. First of all, you need some data and you need some model. Yeah, it's the first part. Next part is that you need to think beforehand how you will deploy it. Yeah, you need to know which hardware you will use because some hardware requires specific models. For example, there is Jetson Nano, there is Neuron, there are many other chips, and you need to convert your model into them. And when converting, often there are some restrictions. So for example, you can't use some very advanced layers, yeah, or you can't use an image in a very high resolution because the device doesn't have enough memory. Yes, so you need to think beforehand about this if you have device. Yeah. On the other hand, if you are simply like if you are going to make a pet project and use this model on your laptop, you don't need to spend some time on it, and you can simply train a model and make prediction here. Yeah. So the first step is to understand on which device will you deploy the model, yeah, and then decide on the model based on the limitations of this device, yeah, and that's the main step. So read documentation about how to do it. Can you talk about your work at Karim? Interesting problems you try to solve with machine learning. Well, I can say that I'm working in anti-fraud department, but currently I'm not free to share information until I complete the projects. So maybe I'll be able to give a talk about my projects in half a year or in a year. Currently, I can't share this information. Yeah, that's it.
Okay, Andrey, I have a question from my
Yes,
side.
sure.
Like, what are the various tools to build data science pipeline, like which will integrate all the following, like data set creation, pre-processing, training, production, and post-processing?
Oh, it's a good question. And I think that in most cases, it isn't possible to have a single pipeline for all these steps, because often they are done in separate systems. For example, I could talk about my medical chatbot project on which I worked 2 years ago. So first of all, data collection. To collect the data, we parse the data from forums from many open databases, open data sources. It was one step. Next, we needed to label the data. For this, we used an open source Docana. We loaded the data there, and our team of special team labeled the data there. Yeah. Next, we take this data, we analyze it in Jupyter notebooks because there are many things to analyze for it. After that, we train the models. I used my own pipeline. Some of my colleagues used my pipeline too. Several of them used their own pipelines. So we had the models. And then we needed to deploy them. We had pre-written code for backend, and we needed to make the models work in it. So we wrote special code to make inference of these models. So in this case, as you can see, we had multiple steps. Each of it had a separate code, and often they weren't connected with each other. Yeah, so a job often it's not possible to have a single pipeline for all the steps. There will be multiple small parts of it distributed in different environments, I suppose. Yeah.
Okay, thanks for answering.
What, we see another question. What are major libraries we need to know besides Pandas, Escalon, NumPy, Keras, TensorFlow, MLflow, and so on? Well, it depends on the task, but I'd say that in most cases, these libraries would be enough. And I would add some libraries for visualization. Seaborn, Matplotlib, Plotly, Altair, and so on. So basically, you need some libraries for processing the data, some libraries for plotting the data, some libraries for training machine learning models. You could also try some libraries for working with databases, like working with SQL, yes, so that you can write some SQL queries. Can you give examples of open medical data that you used from medical chatbot? Well, it's problematic because this medical chatbot was in Russian. Yeah, it was for Russian language. So we used open data in Russian language. We used forums on which people shared some information, talked with each other. We used the websites of different medical organizations. We used some logs which were available. And they were specific to Russian, so I'm not sure if other people will be needed for English language projects. If you have some questions about OpenCV, you can write them, but I suppose it's like a completely different topic from my current talk. Another question is, which framework is important, Flask or Django? I'd say it depends on the use case. For example, Flask is easier to use. It's simple, and you can use it for your small project. If you want to have some serious websites with a lot of functionality, Django would be better. currently, I know that there is a fast API library which is becoming more popular than Flask. Yeah, and also, as far as I know, in fact, if you need to deploy a simple model and that's it, you could use Streamlit or Gradio website. Streamlit is a very simple library which allows you to deploy simple applications or to make predictions with the model, and Gradio will allow you to deploy your own model and let other people make predictions with it. Okay, I see another Q&A. Is JAX a better framework to switch? Well, I suppose this question is thanks to the recent article about JAX overtaking TensorFlow. I'm not sure myself. Currently, I'm using PyTorch, yes, and I like it. As for comparing TensorFlow and JAX, I think most of people who use TensorFlow are either from Google or work with TensorFlow as a legacy framework at their project, yeah, or they have some specific functionality which isn't available in PyTorch. But a lot of people use PyTorch, and well, the question is what you're using now. If you're using TensorFlow, maybe it's worth switching to JAX. If you are using some other library, maybe it's better to wait for some time and not do it immediately. How can we specify particular location to detect in webcam by using OpenCV? If you mean that there is a big, you have a webcam, you have a video, and you want to run the model on the specific part of the screen, then you could use NumPy and simply slice the image and use only the area which you are interested in, and then run the model over it, for example, I suppose. Next question is, which is better one, PyTorch or Keras? It's difficult to compare these libraries. I suppose that if you don't need to make a complicated model, if you want to just run, for example, a simple image classification model, Keras is easier to use. It's simpler, it's lighter, and it requires less code. But if you want flexibility, if you want to change many things, if you want to adaptize your pipeline for your own specific case, then PyTorch is better and easier to use. Yeah. Okay, I think that's it so far.
Yeah. Okay, so I think most of the questions, I think all of the questions are covered. And to all the attendees, I would suggest that if you can check out with our platform, Analytics Vidhya, you will find most of the resources to kickstart your journey in this data science domain. And please go and check out our blogs for free certifications. I guess you will definitely find it useful, and you can also go through some previous recordings on the YouTube link I'm again posting in the chat box. And I think all of the questions are covered, so we can wrap up the session. Thanks a lot, Andrey. On behalf of Analytics Vidhya, I would like to thank you for your time and delivering such a wonderful session. I'm sure our audience found it insightful, and hopefully we can conduct such more sessions with you in the future.
Yes, sure. And thanks to you and thanks to everyone. This was an interesting session and very interesting questions. It was interesting and fun for me to take part in it.
Thank you. Thanks a lot for joining.